Welcome. I'm going to talk about quantum numbers and electron orbitals. This is not meant to be a comprehensive overview, but rather a visual aid that will help you think about these things. I'm going to start by putting up a board-like model up on the screen. In the center we have a nucleus, and around the nucleus we have these orbits. The orbits represent the energy levels or energy shells where the electron might be. And they are given a value of n. N increases the further you go away from the nucleus. So it starts with 1, 2, 3, and 4. Note that n has to be a whole number. So it cannot be something like 2.5 or 3.1. It has to be an integer, 1, 2, 3, 4, and so on. This n is also known as the principal quantum number. Principal, I'm going to shorten quantum number to Qn. Now what you have to understand is that within each one of these orbits there are subshells, and we're going to now have a look at them. So if I can just move the screen. So what we are going to do, let's zoom back, we are going to zoom in on each of these levels or shells and see what's going on in there. So here's n again, so this is our principal quantum number, and when that equals 1, we only have one subshell, the subshell S. When n equals 2, we have two subshells, S and P. When n equals 3, we have three subshells, S, P, and D. And when n equals 4, we have four subshells. Now each one of these subshells, so S, P, D, and F, they have their own value assigned to it, value L. So for S, L is 0, for P, L is 1, for D, L is 2, and for F, L is 3. Now this L is also known as the angular momentum quantum number. So angular momentum quantum number. However, that is not the end of the story. Each subshell can carry a certain number of orbitals within them. So nestled within the S subshell is a single orbital, an s orbital. Nestled within each p subshell are three orbitals. Within each d subshells we have 5 orbitals, and within each f subshell there are 7 orbitals. The orbitals themselves have a quantum number assigned to them as well, and this is known as the ML value, or the magnetic quantum number. So, magnetic quantum number. And finally, each orbital can carry 2 electrons. And these electrons have an ms value. And there are only 2 possible ms values, either a positive half or a negative half. And that depends on whether the electron is spinning up. In that case it gets a positive half, or spinning down. In that case it gets a negative half. And this ms is known as the electron spin quantum number. So it is electron spin quantum number. And those are the 4 quantum numbers. Now, these quantum numbers together, the whole set, can be seen as a postcode for each electron. No 2 electrons can have the same postcode or the same set of quantum numbers. So, for example, if we look at this electron here, what is its quantum address? Well, n is 3, so that is its principal quantum number. It is in the p subshell, which has an L value of 1, so L is 1, it is in this orbital here, which is -1, so Ml is -1. And finally, I've drawn it as spinning up, therefore Ms is +½ Equally, if I placed another electron here, so if I gave it a neighbor, what would be the quantum address then? Well, N will still be 3, L will still be 1, Ml would still be -1. However, Ms, now that it is spinning down, has to be -1/2. And just to hammer the point home, let's say if we added another electron here, what would be its quantum address? Well, let's write it up here. So N for this one is 4, L is 2 because it's in the D subshell, Ml is -1, and finally Ms is +½ because I have drawn it as spinning up. So to recap, we have 4 quantum numbers: N, the principal quantum number, which gives the energy and the number of subshells; L, the angular momentum quantum number, which describes the shape of the subshell, S, P, D, and F, and we will talk about these shapes later on; Ml, the magnetic quantum number, which relates to the orientation of the orbital in space, and we will talk about that later when we talk about the shapes of the subshells; and finally we have Ms, which is the electron spin quantum number, which can have only 2 values, either +½ for spinning up or -½ for spinning down.